So how do computer keyboards work? Have you ever wondered what happens when you press a key on your keyboard? I mean, sure, something shows up on the screen, but what's actually happening? It turns out there's quite a bit going on behind the scenes. So join me as we explore the technology behind keyboards. We'll cover what makes up a keyboard, how key presses are detected and translated into digital signals that your computer can understand. And we'll even take a look at some of the newer technologies that are just starting to hit the market. So whether you're a gamer looking for the edge in a fast-paced online game, or just someone who wants to know how the things they use every day work, stick around. We've got some awesome stuff to show you. First off, let's break down the basic parts of a keyboard. All keyboards have a few essential components: keycaps, switches, a printed circuit board, a controller chip, and connectivity. Let's start with the keycaps. These are the plastic tops that you press on the keyboard. They're usually labeled with letters, numbers, symbols, or even pictures, depending on the type of keyboard you have. One of the cool things about mechanical keyboards is that the keycaps are often removable and replaceable. This means you can customize your keyboard to look exactly the way you want it to. Underneath each keycap is a switch, which is the mechanism that registers the press. There are three main types of switches: mechanical, membrane, and scissor switch. Mechanical switches are individual spring-loaded switches that when you press them, move down and make contact with a metal leaf, triggering an electrical signal. Scissor switches are similar to mechanical switches, but have a lower profile, making them quieter and often used in laptops. Membrane keyboards use a rubber dome that collapses when you press it. This presses down on a layer of conductive material below it, completing a circuit and sending a signal. Each of these switch types has its own pros and cons. Next up is the printed circuit board, or PCB. This is essentially the brain of the keyboard. When you press a switch, it sends a signal to the PCB, which then sends a signal to the controller chip, telling it which key you've pressed. The controller chip converts the physical press into a digital signal such as USB or HID and sends it to the computer. Now the last piece of the puzzle is connectivity. Most keyboards connect to your computer through a USB cable, providing a direct connection with minimal latency or delay. Some keyboards also offer a wireless option like Bluetooth or RF, which uses a small USB dongle that plugs into your computer. Now that we know the basics, let's take a closer look at how keyboards detect key presses. As we mentioned earlier, mechanical keyboards use individual switches under each key. When you press a key, the switch moves down and makes contact with a metal contact, completing a circuit. This tells the PCB that this particular switch has been activated, and it sends a signal to the controller chip. The controller chip then converts this signal into something your computer can understand. In a membrane keyboard, the rubber dome on the switch pushes down on conductive pads on the PCB, completing the circuit and sending a signal. Similar to mechanical keyboards, on a laptop, the scissor switch keyboard uses a hybrid approach, combining aspects of both mechanical and membrane designs. Because of the shorter key travel distance on a scissor switch, the overall profile of the keyboard is thinner and more compact. One thing to keep in mind is that keyboards have a built-in feature called debouncing. What's debouncing, you ask? Well, it's a process that prevents duplicate signals from being sent. When you press a key only once, imagine you retyping on your keyboard, and every time you press a key, it registers as multiple keystrokes. Not good. That's where debouncing comes in. Basically, the keyboard has a built-in timer that ignores any additional signals until a set amount of time has passed since the original signal. This prevents duplicate inputs and ensures that your computer receives only one signal for every key press. Another important feature of keyboards is key rollover. This refers to how many keys can be pressed simultaneously and have all of them be registered correctly. Most keyboards have 6 NKRO, or 6-key rollover, meaning that they can register up to 6 keys being pressed at the same time. However, some gaming keyboards support NKRO, or unkey rollover. This means that you can press any number of keys at the same time and they all be registered. Alright, now let's talk about some special features you might find on high-end keyboards. RGB backlighting is a popular feature on many gaming keyboards that allows you to customize the color and effects of the lights underneath the switches. To do this, the keyboard has LEDs placed underneath each switch, which illuminate the keycap from below.
Ow!
The software allows you to create different patterns, customize colors, and even synchronize the lighting with other compatible devices. Macro keys are another common feature found on gaming keyboards. These are additional keys that can be programmed to perform a series of actions or macros with a single press. For example, you could program a macro key to launch a specific application along with any number of keyboard shortcuts. This can come in handy for tasks that require multiple keystrokes or for gamers who need quick access to certain commands in a fast-paced environment. Last but not least, wireless connectivity is a convenient feature that allows you to use your keyboard without the constraints of a physical cord. There are two main types of wireless keyboards: Bluetooth and RF. Both options allow you to connect multiple devices, but Bluetooth is more versatile as it can connect to a wider range of devices, including laptops, tablets, and phones. Speaking of gaming, did you know that higher-end gaming keyboards often use optical switches instead of traditional mechanical ones? Optical switches use light beams to detect key presses rather than metal contacts. This results in faster response times and increased durability. But that's not all. Some bleeding-edge keyboards are even incorporating AI to predict what you're going to type next. Yes, you heard that right, AI keyboards. While still in their infancy, these keyboards could change the way we interact with our computers by offering a more predictive and intuitive typing experience. Who knows, maybe someday we'll have keyboards that can help us write our scripts. As you can see, modern keyboards are sophisticated devices with many moving parts. From the intricate design of mechanical switches to the advanced circuitry involved in processing keystrokes. There's a lot going on behind the scenes to ensure that every press is registered accurately and efficiently. Whether you're a casual user or a hardcore gamer, hopefully now you appreciate the complexity and engineering that goes into one of the most essential PC components. And hey, if you want to learn more about keyboards, check out this video about the difference between Cherry MX, Gateron, and optical switches. Thanks for watching and happy typing. So how does a keyboard work? First, the keycap you press activates a switch. In a mechanical keyboard, this moves a metal contact, completing a circuit and sending a signal to the PCB. In a membrane keyboard, the rubber dome pushes conductive pads together, also completing a circuit. This signal is then converted by the controller chip into a digital signal that the computer can understand. If you enjoyed this video, remember to give it a thumbs up and subscribe for more tech explained content. And if you have any questions, drop them in the comments below.